Hello, in this Tech Talk video I'd like to talk about ERDAS Imagine 2018 having introduced a new operator called Pan-Sharpen by NNDiffuse. It's a new operator which enables a model to be built which performs nearest neighbor diffusion based resolution merge as described by the paper by Sun, Chen and Messenger. Let's go ahead and start out looking at that. And of course, pan sharpening is that old chestnut where we have multispectral, multi-band, lower resolution imagery combined with panchromatic high resolution imagery. And what we want to do in pan sharpening is basically combine the two. We want the high resolution information from the pan, but to retain the color from the multispectral information. And then NNDiffuse is a new technique which is becoming very popular in the industry as a way of doing the pan sharpening across a broad array of different sensor types. So we're going to go ahead and try and do that with this digital globe data that I have displayed here. So we're going to cheat a little bit and we're going to go ahead and open up the spatial modeler and start with an existing model by coming to the raster tab, and on the pan sharpen pull down we're going to select the new technique of NNDiffuse. And then on the NNDiffuse pan sharpen dialog that we could just go ahead and use straight away, we're going to hit the edit button to basically load up or start spatial model editor and preload a model that performs the NNDiffuse pan sharpening. So let's go ahead and left click on the pan sharpen by NNDiffuse operator. I'm just going to expand our properties dialog, and you can see that the NNDiffuse operator has 4 input ports and 1 output. The first 2 ports basically take the panchromatic and multispectral input raster information that needs combining, and then there's a couple of optional ports that let you set parameters on how sharp or smooth you want the data to be, and what weighting you want to give to color retention, color fidelity retention, or sharpness. So you can see that right there. And we can go ahead and preview that model. Let's just sort these things out a little bit. I'm going to clear this view and I'm going to click preview, and I'm going to go ahead and select my data. I'm going to use right mouse button and use my recent lists because I've already accessed this data. So we're going to go ahead and pick the high resolution panchromatic and the multispectral lower resolution data. I'm previewing, so I don't need an output file and I don't need to specify the optional parameters. Go ahead and click OK, and basically that will on the fly process the data and display it into the preview viewer. So this isn't actually writing the data to disk at this point. We can still pan around and look at the information, and you can see the processing will fill that information in as we pan around the data and look at different locations. Now, the true power of the spatial model editor comes in the ability to quickly create spatial models and modify existing ones. So we started with a basic model right here that just takes in the 2 input images and processes them and spits out a result. And we want to go ahead and modify that and enhance this capability. One of the things that often happens when you're doing pan sharpening is that because the data range may get stretched, especially on the multispectral data, it may grow or contract in the minimum and maximum data values. Sometimes you can get holes appearing. The data may become stretched across a range which drops below 0 into the negatives. You then truncate that off when you output, say, an unsigned 16-bit integer output. But in truncating that extended range, you might end up with what are perceived as holes, with locations of zero value in your data. So we actually, what we're going to do here is show the power of a spatial modeler by just going ahead and modifying the model very quickly and easily to avoid introducing zeros. And we can do that using the concept of no data masks within Spatial Modeler itself. We can certainly keep track of no data locations via a mask within the processing areas. So actually in Spatial Modeler, when processing, you shouldn't get those holes introduced. But when I write a file out at the end of the process, which is generally what most people want to do, some formats don't support mask-based no data locations, and those can get confused when you have to convert and use a value-based no data. So let's go ahead and make sure that no erroneous zeros get introduced into my pan-sharpened output data. Actually, the first thing I'm going to do here is let's turn the preview off so I can maximize my canvas space, just so we can see what is going on as I edit this model. Zoom in a little bit perhaps. And we're going to go ahead and not modify the version of the NNDiffuse that's built into Imagine. We're going to save off my version using File, Save As, Spatial Model As, and give it a file name. Let's call it my NNDiffuse. Replace it if it already exists. And one of the things the pan sharpen by NNDiffuse operator does do automatically is it outputs data in the same data range as the data type of the multispectral imagery. So you can see here it's outputting an unsigned 16-bit. And that may vary. If I input some 8-bit data or some float point data, it's certainly going to default to that. But I want to go ahead and make sure my model, when I output my final raster output, after I do these other operations in the model, is going to remain the data type of the pan sharpened imagery. So let's go ahead and we're going to use a operator called raster information. So if I could go ahead in the operators panel, start to type information. And I can find the raster information operator, drag and drop it onto my canvas. I'm going to connect that. It has an input raster port, so we want it to check on the output of the NNDiffuse operation. So right click on that operator and say run just this, and it'll go ahead and calculate that leg of the model. And you can see, sure enough, the fourth port down here is saying that the output of this particular operation is unsigned 16-bit data in this instance. We don't need most of these other output ports, so I'm going to go ahead and in the properties panel I'm going to go ahead and turn off all the ports that I don't actually intend to use, just to neaten up my model, make it look or easier to read. And we're going to select the raster output and instead do the opposite. We're going to turn on the pixel type port. Just reorganize these a little bit by left dragging and dropping. We're going to take that unsigned 16-bit definition and say, okay, seeing as my pan sharpening is producing unsigned 16-bit, we want to make sure that any raster output we create is also going to be created as unsigned 16-bit, so we don't waste any data storage space unnecessarily. Next, what we want to do is check for those locations that might be less than a value of 1 and make sure as part of the model we set those the specific way we want. So to check for those locations, let's type less in my filters, so we want less than or equal to, so I'm going to drag and drop that particular operator into our model. And again, what we want to check is the output of this NNDiffuse operation, so we're going to feed that in as input 1, and then input 2, I'm going to come into the properties tab and type 1, return. So this is going to perform a check. It's going to check and see if any pixel location has a value of less than 1. And obviously at those locations we want to do something. So the next thing is that we want a conditional statement. Type conditional. And what we actually want here is just a very simple either or operation. So we're going to grab that particular operator and drag it in. So we're gonna, its first port is the test, so we're going to hook that up to the less than or equal to 1 test. So that's going to say perform this test, and if the test is true, do one thing, and if the test is false, do something else. That's the other 2 ports that are on there. So what we'll want to do is say, okay, output if true port. So if the test is true, i.e. if the pixel, the values at the pixel location is less than 1, we actually want to go ahead and set it to a value of 1. So we should have no values less than 1, because they're just going to get reset to 1. And otherwise, at the other pixel locations that are greater than or equal to 1, we're just going to feed out the original pan-sharpened information. So we're just going to move these operators around a little bit. And of course what we want to do now is, rather than previewing that particular information, we're going to preview the data that's had anything less than 1 replaced as 1s. And this doesn't mean to say that if you have no data locations in your input data, those aren't going to get converted into 1s, because Spatial Modeler, as I mentioned earlier, uses no data masks. Any pixel locations that fall under the original no data mask are going to remain no data. It's just those erroneous locations of actual imagery locations might accidentally get stretched to less than 1 and then get truncated to 0s or less. We want to make sure that those stay as valid image pixels. So we're going to set those to 1, and the no data mask is going to get set out when we produce the output file. So we've made the modifications to the model that we want to use. Actually, we also want to go ahead and disconnect this from the raster output. We actually want the results of that conditional to be going to the raster output, so we drag and drop between the ports to do that as well. And let's go ahead and save. Come up here to the quick access toolbar, click save to make sure we've saved the copy, the my NNDiffuse.gmdx model. And then we're going to click run. It's remembered from last time the inputs that I used. This time we definitely want to go ahead and name an output file. So we call it NNDiff2 and click OK. And then this time, rather than previewing the results in real time to a 2D view, we're actually producing a file on disk. That obviously will take a little bit longer than just previewing. Previewing is in real time, but when we're doing the processing and writing a file out to disk, it takes a little while longer. So let's come back when that's finished. So here we go, the model has completed. Let's go ahead back to the Home tab, create a new 2D view, and we'll have a look at the results of the model. We're going to go ahead and use the recent list again for my file and bring in NNDiff2 that we created. And we can zoom in on that location of aircraft that we saw earlier. Go to 1 to 1, perhaps zoom in 2 times. And let's go ahead and open the original multispectral over the top and perform perhaps a swipe. Let's just expand that out a bit, and we we can go ahead and swipe the results. Hopefully you can see very good color retention, but obviously vastly improved spatial resolution as the panchromatic information, the high resolution panchromatic information, is merged with the color of the multispectral 4-band input imagery, producing high-res 4-band output in this instance. So that's good. Let's go ahead, come back, I'm going to close out my transition. We can turn that off. You see the multispectral, the high resolution over there on the right. And you see our model. So just to reiterate, we've created a modification very quickly and easily to look for potential introduced holes in my pan-sharpened dataset. We've used the new pan-sharpened by NNDiffuse algorithm, avoided and added the capability to avoid introducing holes using the spatial modeler very quickly and easily. Thank you very much for watching this Tech Talk video. Hopefully you enjoyed it and found it useful. Please come back and see some of our other videos as well, and everybody stay safe.